is Suresh Gyan, Assistant Professor in the University of Pharmacy. We are part of the Suresh Gyan Vihar University in Jaipur. So today we are going to discuss this topic, that is the classification of chemicals. When it comes for student in the chemistry course in the second semester. So So here we are going to discuss about the learning objective of this topic is that we are going to learn about the introduction of IPEC nomenclature, and also we are going to study about the priority sequence of naming objects and topics. The student outcome is that they will going to know about the introduction of IPEC nomenclature, and also they are going to study about the priority sequence of naming organic compounds. So here the learning objective is here we are going to learn about the introduction of IPEC nomenclature and to study about the priority sequence of this naming organic compound. And the student outcome is that we are going to they will be going to know about the introduction of IPEC nomenclature, that how we are going to nominate the organic compound according to the IPEC system. And here, here also we are going to discuss about the priority sequence of naming means here we are going to discuss about the priority sequence, means which function is coming on the first priority. After that, which function will come, and according to that priority sequence, we are going to name the organic compound which is containing a different functional group in it. So here we are going to discuss about all of these things. Means here we are going to discuss about the IPEC nomenclature as according to the priority sequence present in the chemical compound that is having different function group in it. Next is the introduction. So here, the purpose of the IPEC system of nomenclature is to establish an international standard of naming in compound to facilitate communication, and the role of the system is to give each structure a unique and unambiguous name and to correlate each name with a unique and unambiguous structure. Means here that the purpose of this IPEC system of nomenclature means the purpose of this naming according to the IPEC nomenclature, IPEC system of different compound is to establish. Means here we are establishing our international standard, so that if we are naming here in a particular compound, we are naming and if we are going somewhere else in a different country, and there also we are naming, if the system was different, then we cannot understand the compound name. So here, that is why we are developing a system, that is the IUPAC system, that is helping to name a chemical compound and to understand that what chemical compound is that, so to facilitate its communication. So there we are this IPEC system is also helpful in communicating. It also helpful in facilitating the communication in different countries. If we are naming this, if we are naming the organic compounds in that. So here the purpose of this IPEC system of nomenclature is that we are establishing an international standard of naming compounds, so to facilitate our communication, and the goal of the system is to give unique structure, a unique each structure unique and unambiguous name, and to correlate each name with a unique and unambiguous structure. Means here we are the goal of the system, means the goal of this IPEC system is to give a structure a unique and ambiguous. Means here we are giving a structure, a name, a unique name that it cannot be mixed up with any other thing. If this both name will be same for one structure, then it will be very confusing to identify that which structure is this. So that is why we have developed this system, this IUPAC nomenclature system, so that we can name our compound differently, and every compound has its unique name. So there will be no confusion between the one compound which is having the two names. So here, every structure is having a different name, and every structure is different. So the purpose of this IUPAC system, so the purpose of this IUPAC system of nomenclature is to establish. So here we are establishing an IUPAC. We are establishing an international standard of naming compound, so that we are facilitating the communication. The goal of the system and the goal of the system is to give, and the goal of the system is to give each structure, and the goal of the structure is to give each structure a unique and unambiguous name, and to correlate each name. So we are correlating each unique name of the structure with the unique and unambiguous structure. So here, the introduction in the introduction we the introduction means here that we are the purpose of this introduction of the IUPAC system of nomenclature, that we are establishing or developing an international standard for naming the different compounds to facilitate communication, and the goal of the system is to give each structure a unique and unambiguous name, and so that we can correlate that name, each name with a unique and unambiguous structure. In this, the first is your fundamental principle. In this, the IUPAC nomenclature is based on naming the longest chain of carbon connected by single bond, whether in a continuous chain or in a ring or derivation, either multiple bond or atoms other than carbon and hydrogen are indicated by prefixes or suffixes according to a specific set of priority. So the fundamental principle of this IUPAC nomenclature is based on naming a molecule longest chain. Means here we are naming the longest chain of carbon that is connected by a single bond, whether in whether it is a continuous chain or it is in a ring, or if there is any deviation, either there is a multiple bond or atom other than carbon atom, if there is any carbon other atom other than carbon atom, carbon and hydrogen, when they are indicated by the prefixes and the suffixes according to a specific set of values. Means if there are any other atoms present in the chain or the longest chain or a ring, then these prefixes we can show their meaning by these prefixes or the suffixes. We can write their name by writing the prefixes or the suffixes according to their specific set of values. On the basis of the priority, we are naming, we are just giving the name in the in uh, indicating by the prefixes or the suffixes if any deviation is there in the chain. So here, in the fundamental principle, there is that the IUPAC nomenclature. So the IUPAC nomenclature is based on the principle, is based on naming a molecule, the longest chain of carbon connected by a longest chain of carbon that is connected chain of carbon that is connected by a single bond, whether in a continuous chain or in a ring. Means here, the IUPAC nomenclature is based on naming a molecule, longest chain of carbon and connected by a single bond, whether in a continuous chain or a ring, and all deviation either that is a multiple bond or atoms other than carbon and hydrogen are indicated. So these are indicated by the prefixes and suffixes according to a specific set of priority. So here the introduction of this IUPAC system of nomenclature. So in the introduction of the IUPAC system of nomenclature, the purpose of this IUPAC system of nomenclature is to establish an international standard. So in this international standard of naming organic compounds, so that we can facilitate the communication and uh, and the goal of the system is to give structure. Means here the goal of the system means the goal of the IUPAC nomenclature system is to give each structure a unique and unambiguous name, and after that a unique and unambiguous name, and to correlate each name. So if we are giving each name, each structure, if we are giving a unique and unambiguous name to each structure, then we have to correlate each name with the unique and unambiguous structure also. That this compound, the name of this compound is related to this structure, uh, and there should be no correlation between one structure which is having the two names, because we are developing that system so that each structure is having each unique and unambiguous name. So next is your fundamental principle. So in the fundamental principle, the IUPAC nomenclature is based on naming a molecule, longest chain of carbon that is connected by longest chain of molecule that is connected by single bond, whether in a continuous chain, or in a ring. So the IUPAC nomenclature is based on naming a molecule longest chain of carbon that is connected by a single bond, whether in a continuous chain or in a ring. All deviation, either multiple bonds or atoms other than carbon and hydrogen. So here, is this nomenclature is based on naming a molecule which is having the longest carbon chain and that is connected by a single bond, or whether this longest chain is in a continuous chain or in a ring. So all deviation, either multiple bond or atom other than your carbon and hydrogen are indicated. So these are indicated by prefixes and suffixes according to the specific set of priority. So these deviations, either multiple bond or multiple bonds or atom other than your carbon and hydrogen are indicated by your or prefixes and suffixes according to a specific set of your priority. Next is nomenclature in organic chemistry. So how we nomenclate in organic chemistry. So it is important that organic compounds are correctly and unambiguously named so that there can be absolutely no confusion about what compound are actually being reported or described. There have been many conventions for naming organic compounds. The IUPAC, the International Union of Pure and Applied Chemistry, periodically reviewing naming practice, attempting to standardize nomenclature, and the following guidelines for organic nomenclature are based on the definitive rule published by IUPAC, International Union of Pure and Applied Chemistry. So nomenclature in organic chemistry is important. It is important that organic compounds uh, uh, are correctly and unambiguously named. So there can be absolutely no confusion about what compound are actually being reported or described. Means here each organic compound should be correctly and ambiguously named. So there will be no confusion. There will be no confusion about what compounds are actually being reported or described. Means here that these are absolutely so there should be, they are completely and unambiguously named so that there can be absolutely, so there can be absolutely no confusion. There should be no confusion about what compounds are actually being reported or described. Means here that it is very important. It is very important that we should uh, we should name the organic compound correctly and in our unambiguously name. So that there can be absolutely, so there can be absolutely no confusion. So there should be no confusion about what compounds are actually being reported. So there should be no confusion about what compounds means, which compounds are being actually being reported or described. And there have been many conventions for naming organic compounds, periodically reviewing naming practice and attempting to standardize nomenclature. So there have been many conventions for naming these organic compounds. That is the IUPAC, the International Union of Pure and Applied Chemistry. Periodically, this form is periodically reviewing the naming practices as well as for attempting to standardize nomenclature so that we can nomenclate in standardly nomenclate and the following guidelines. There should be a guideline for naming in the organic for the organic nomenclature based on the definitive rules, rules that are published by the IUPAC, the rules that are published by the IUPAC. So there are a following guidelines for naming the organic compounds, which are based on the definitive rules published that was published by the IUPAC system. So here, nomenclature in organic chemistry. So once again, that it is very important that organic compounds are collectively and unambiguously named so that there can be absolutely no confusion. So there can be absolutely no confusion about what compounds. There should be absolutely no confusion about what compounds are actually being reported or described, being reported or described, and there have been many conventions and there have been many conventions for naming organic compounds. The International Union of Pure and Applied Chemistry and the periodically for naming organic compounds, IUPAC periodically reviewing naming practices, attempting to standardize nomenclature, and the following guidelines for organic nomenclatures are based on the definitive rules. So these are rules that are published by this IUPAC form, and we have to follow that rules. And by applying that rules, we have to nomenclate our organic compound. If we are not no, applying that rule for naming our organic compound, then that meaning should be wrong. That is why there is a system developed, that is the IUPAC system, that is having a special guideline for naming the organic compound, and they have also given the priority to the functional groups so that we can apply that priority sequence before naming the organic compound so that there will be no confusion in naming what the compound is actually being reported or what is it is described. The next review. First review IUPAC nomenclature of alkanes, that is a saturated hydrocarbon. So here the first is your alkane. So how we will nomenclate it according to the IUPAC alkanes. So alkanes are also the saturated hydrocarbons. So there are two hydrocarbons, that is the saturated and the unsaturated. Saturated hydrocarbons are those organic compounds that are having the single bond between the two carbon atoms. They are having a single bond in them. That is why they are the saturated hydrocarbons. Saturation. So here where you will see the saturation, it means they are the alkanes. Next is the unsaturated hydrocarbons. So unsaturated hydrocarbons means that the organic compounds which are having the double and the triple bond. So the organic compounds in which they are having double and the triple bond between the two carbon atoms, then they are known as the unsaturated hydrocarbons. So unsaturated hydrocarbons are means your alkenes and alkynes. So alkenes and alkynes are the unsaturated hydrocarbons which are having the double bond between their carbon-carbon bond. So that is why they are the unsaturated, or you can say they are the alkenes and the ines means here they are having the double bond between their carbon-carbon bond. So they are called the unsaturated hydrocarbons, which are having the double and the triple bond. Next, the names of the straight chain saturated hydrocarbons for up to 5 carbon chains are known below. So here the name of the straight chain means if there is a straight chain, if there is a straight chain, saturated hydrocarbon means if the carbon are bonded to each other by a single bond, then up to five carbon chain means the 5 carbons in a chain are bonded by the single bond, then they are named according to their number. That if it is containing 1 carbon atom, then it is known as your methane. If it is containing the 2 carbon atoms, then it is your ethane. Means in the ethane, the carbon are bonded with each other by the single bond. Next, if they are having 3 carbon atoms, then they are your propane. So in the propane, there are 3 carbon atoms that are attached or that are bonded by the single bond. Next is your 4 carbon atom, that is your butane. In the butane, there are 4 carbon atoms that are bonded to each other by the single bond. So that is why they are your single bond, and that is why they are your butane, or you can say the um, or you can say they are the butane because they are having the 4 carbon atoms, and the 4 carbon atoms are bonded by the 4 carbon atoms are bonded by the single bond. Means this butane is alkane. Next is your 5 carbon atom. So in the 5 carbon atom, they are in this uh, 5 carbon atom. They are bonded by the 5 carbon. They are bonded by the 5 carbon atoms, and in the 5 carbon atoms, they are bonded by the single bond, and this single bond in the five. This is a straight chain, and this is a saturated chain because they are having a single bond that are bonded to each carbon atom, and that is why they are known as pentane. Pentane means your 5, and ane means your alkane. So here in all the name of this saturated alkane, we have seen that their name is they are having the last three alphabets is your ane. So here ane comes from your alkane. So in the alkane, if the alk is removed by this net, it you spend when ane is applied, then they become the saturated hydrocarbon. So in this, the number of carbon atoms that is having the 1, that is known as your methane, that is having the 2, that is your ethane, because in this the 2 carbon atoms are bonded by the single bond. Next is your 3, then this is your propane, and in this the 3 carbon atoms are bonded by the propane. Next is your 4, this is your butane, and in the 5th, that is your pentane. In this, the 5 carbon atoms are bonded by the 5 carbon atoms are bonded by the carbon. 5 carbon atoms are bonded by the single bond. So these are the number of carbon atoms and these are the names. Next is your homologous series of alkane. So homologous series of alkane, as you can see here, that here it is shown that there are 10 alkane molecules, and in this methane is having the structure that is your CH4, and then the ethane is having CH3. So here we can also show it by this a single line, that is not a straight line. This is your ethane. This is your ethane, which is having a single line. Next is your propane. So in the propane, this is your CH3, CH2, CH3, and it is having this two. This is having this two state chains are bonded here, and here you can see this is your C. This here the and is showing here. This is your C. This is your C, and this is your C. So here this is having CH3, CH2, and this is having the CH3. So CH3 one valence is bonded to this another carbon atom, and here the two this carbon is having the two sides are bonded to the two carbon atom. So it is having the CH2, and in this there is a CH3. In this the one carbon is bonded to one carbon atom, that is one is having the three hydrogen atom. So this is your propane. The next is your butane. So in the butane, you can see here CH3, CH2, CH2, CH3. So it is having the 4 carbon atom, as you can see here. So it is having 1, 2, 3, 4. So plus the alkane. So here plus you can see the alkane are having the hydrogen atom because its molecular, because its formula is a CnH2n plus 2. So CnH2n plus 2 means here the hydrogen is H2n plus 2. So if there is one carbon, then there is 4 hydrogen. So there is 4 hydrogen because here CnH2n plus 2. So 2 into 1 plus 2, that is your 4. So that is why it is having the CH4, that methane. Next, in the ethane, it is your CH3. So it is having 2 carbon atoms and it is having hydrogen, which is 6 plus 2, and plus 2 means here 2. We just so 2, 4, 5, 6. So here it is having the 6 hydrogen atom. Now in case of a propane, there are 3 carbon atoms, and hydrogen is your 3, 7, 8. So 2, 3 is 6 plus 2, that is your 8 carbon atoms. So in the propane. Next in the butane, C3, CH2, so it is having 3, 6, 7, 8, 9, 10. So it is having 10 hydrogen atoms because here the carbon is your 4, and 4 into 2 equals to 8, 8 plus 2 equals to 10. So that is why hydrogen atoms is your 10, and it can be represented as this also. It can be represented by this also. So this is your butane, which is showing that this structure. Next is your pentane. So in the pentane, there are 5 carbon atom, and in the 5 carbon atom, this 5 carbon atom is connected to the hydrogen atom, and these are having 3, 4, 3, 6, 9, and 12. So it is having the 12. C5H12. So C5H12 is 5 to the 10 plus 2 equals to 12. So the pentane is having the 12 carbon atom in it. Next is your hexane. So hexane is having 14 hydrogen atom plus 6 carbon atom. So it is having 6 carbon atom, and you can see here this is having hydrogen atom, that is your 14 hydrogen atoms are here. So in this the 14 hydrogen atoms are here, and in the heptane is having the 7 carbon atoms are present, and in this 7 carbon atom, the hydrogen is your So here it is having 7 carbon atom and it is having the hydrogen, that is your 16 hydrogen atoms are present. So as you can see here, the chain is here and it can be shown by this straight line that here the carbons are bonded by single bond. Next is your octane. So in the octane, you can see here that this is having the 8 carbon atom and here it is having the uh, this 8 and 8 is having the 18 carbon atom, 18 hydrogen atoms are there. And then is your nonane, it is having the 20, and then your decane, it is having 22. So this is the homologous series of your alkane, and in the homologous series, you can see the one carbon atom containing is known as decene, with and two carbon, the compound which is having the two carbon that is known as your it, then prop for the 3, but for the 4, and for the 5, X for the 6, F for the 7, off for the 8 carbon atom, non for the 9 carbon atom, and deck for the 10 carbon atom. So this is the alphabet nomenclature of your alkane or the saturated hydrocarbons. The saturated hydrocarbons are those compounds which are having in the single bond attached between the two carbon atoms. So the name of the straight chain saturated hydrocarbon for up to 5 carbon atoms is shown below. That is your 1 is having methane, 2 is having ethane, and third propane, 4 pentane, and 5 is your pentane. So homologous series of these alkenes, you can see it can be also shown by this straight line. So these structures can also be shown by the straight line because it is in the methane there is only one carbon atom, that is why it is shown by the straight chain. But in case of the ethane, it is shown by the straight line because it is having the two carbon atom. So here it can be shown by this straight line also. Next is your. It is very important at this time to stress that since carbon must always have 4 covalent bonds in a neutral compound, the number of hydrogen atoms present in any carbon atom is simply obtained by subtracting the number of bonds from 4 using this method for the molecule 2 to 4 trimethyl pentane. A carbon a carbon is connected to 3 hydrogen bonds. Carbon B is connected to 2 hydrogen bonds, and carbon C is connected to 1 hydrogen atom, and carbon D is connected to no hydrogen atom. So in this, you can see that the hydrogen, as you know, that carbon is having a 4 covalent bond, means it is having a 4 valency, and that is why it is having a 4 covalent bond in a neutral compound. Like in your methane, as you can see that the hydrogen number is your 4. So it is the carbon is connected to the 4 carbon atom. So 4 hydrogen atoms. So in this, the number of hydrogen atom that is present at any carbon atom is simply be obtained. So here the number of hydrogen atoms present at any carbon atom may simply be obtained. It can be obtained by subtracting. So here we can subtract the number of bonds from 4. So here we can subtract the number of bonds from 4 using this method for the molecule 2 to 4 trimethyl pentane. So it is your 2 to 4 trimethyl pentane, and your carbon A. The carbon A is having one less hydrogen atom, as it is having the 3 hydrogen. So it is having the 3 hydrogen atom, and the carbon B, it is having the 2 hydrogen atom, because here you can see in this carbon atom is connected to one carbon atom. That is why it is having the 3 hydrogen atom. And in this carbon atom, it is connected to 2 bonds. That is why it is having the 2 hydrogen atom. And in this, it is connected to this 3 carbon atom, these 3 bonds. So that is why it is having the 1 carbon atom, 1 hydrogen atom. And in this D, it is connected to the 4 different carbon atom, and that is why it is having the it is having It is not connected to any hydrogen atom. So in the case of B, there is no hydrogen atom present in it. So that is why name is 4-trimethylpentane. Means here you can count from this carbon atom 1, 2, sorry, from here 1, 2, 3, 4, and 5. So on the second position, there are 2 methyl groups, and on the fourth position, there are 1 methyl group. So here 2, 4. So 2, 2, 4. On the fourth, there is a methyl group. So that is why here tri is written here. So these are the methyl groups that are bonded to this carbon atom. So and the straight chain is your pentane. So its name is your pentane. So its name is 2,2,4 trimethylpentane. Again, I'm telling you that it is very important at this time. Since carbon is having 4 covalent bond, the carbon is having a 4 covalent bond in a neutral compound, like your methane that is having the CH4, it is having the 4 carbon atoms. So the number of hydrogen atoms, present at any carbon atom may simply be obtained. It can be obtained by subtracting the number of bonds from 4. So from 4 we can subtract if any carbon atom is attached to any other functional group or any other carbon atom. So here we are using this method in which we are connecting it with the this 4-trimethylpentane. So in this carbon A, carbon A is connected to 3 hydrogen atoms. This carbon A is connected to 3 hydrogen atoms. Carbon B is connected to 2 hydrogen atoms. Carbon C is connected to 1 hydrogen atom, and carbon D is connected to no hydrogen atom. As you can see in this structure, that the carbon A is connected to only 1 carbon atom. That is why it is having 3 hydrogen atoms. And in the B, it is connected to 2 carbon atoms. That is why it is having 2 hydrogen atoms. And in the C, you can see it is connected to the 3 carbon atom. That is why it is connected to 1 hydrogen atom. And the D, that is not connected to any hydrogen atom. So it is having no hydrogen atom present in the carbon atom. Its name is 2,2,4 trimethylpentane. Next, carbon is classified as being primary as it is attached to only 1 other carbon atom, and the hydrogen atom bonded to carbon A are known as primary hydrogen atom. So extending this concept leads to the designation of secondary for carbon B and the tertiary for carbon C and the quaternary for carbon D. So you should be able to quickly determine that the compound above contains 15 primary hydrogen atoms, 2 secondary hydrogen atoms, and 1 tertiary hydrogen atom. So the next we will discuss about the priority listing of all the prefixes and suffixes we use for naming organic molecules containing these functional groups. So in this, the functional group that is having the priority, this is having the priority carboxylic acid, and so here you can see this is the carboxylic acid, as there is a this functional group is attached. This is your COOH. So it shows that this is your carboxylic acid. Next is your ester. So it is having this COOC. So it is having this CROOR. So it is your ester. So in the ester, this function group is there is an this function group is showing, and this is your ester, and here the name is written as OH. OH, we apply the suffix as OH. Next is your amide. So amide is having the functional group that is your CONH2. So CONH2 is your amide. CONH2 is your amide, and in this the name is your amide. Alkanamide. Alkanamide. We apply N is removed from here and E from removed from here, and there is the application of this amide. So its name is amide. So on the nitrogen, the propyl group is attached, and this side is your ethanamide. This side is the 2 carbon atom. That is why its name is ethanamide. And from this nitrogen atom, Propyl is attached, means that three carbon atom chain is attached to it. That is why we have right here. We have written here N propyl ethanamide, and this is your amide CONH. So this is your amide. Next is your butanol. So butanol, the functional group is your CHO. So this is the functional group, that is your CHO. Next is your ketone. So this is having the functional group, that is your CORCOR. Its name is 2-pentanol. 2-pentanol. Ketone. Next is your hexanol. The hexanol, it is having the all, that is your alcohol group is attached to it, and its name is your all. So we will apply this all to the name as it is having the alcohol. So here this COOH is applied to that chain if it is having this carboxylic acid, and if the suffix that is applied is your oic acid. In case of this ester, here the RCOOR, so it is your ester, and here we apply this ethyl propyl. Next is your N-propyl ethanamide. So in this case, this is your CONH. So in this case, its name is N-propyl ethanamide. Next is your butanol, because it is having the CHO function group, that is your aldehyde. Then your ketone and your hexanol. Next is your amine, that is having only NH2, RNH2. Alkene, that is having the triple bond, and pentine or your alkyne, that is having the triple bond. Next is the alkyl halide, that is having these halides on them, means the halogen groups are attached to it, your fluorine or fluorine. Next is your ether, and in the ether ROR. In the ether, its name is ethoxy propane. You can write ethyl propyl ether. And next is your cyclic group is attached to a benzene group, so its name is alkyl benzene. Next is your alkane, because there is no double bond, and group is attached, only a single bond are attached between the carbon atoms, so its name is alkane. Next, these are the priority sequence and the prefixes and the suffixes that should be applied. So it's function group, prefixes and the suffixes, and this carboxylic acid is having the highest priority. So this is your carboxylic acid, that is having oic acid in the case of ester, oic, and in the case of amide, its name is your amide. And in the function group aldehyde, prefixes carbonyl or formyl, and the suffix is your al, ketone oxo, and the suffix is your ol. And in case of alcohol, it is your hydroxy, and the suffix is your ol. Amine, amino, amine, and alkene, alkenyl, alkene, alkenine. In case of a triple bond, it's anyl and the ene. Next, this is the subordinate groups, and the subordinate the principal function group are listed in decreasing priority, and the subordinate function groups have no established priority. So the function group at the top of the list, carboxylic acid, has the highest priority of naming, while the function group at the bottom of the list has the lowest priority for naming, and the compound that contains several function groups can be named by finding the function group with the highest priority and completing the name with the appropriate suffix. So the presence of other function group can be indicated by using this appropriate prefixes. These are the subordinate groups. Next, if you here some of the structures are given, and they are having the 4 isomeric compounds, that is your A, B, C, and the G, and they are having the molecular formula, that is your C5H9BrO2, and the compound A has carboxylic acid. As part of the longest chain of 4 carbon atoms, with the Br atom connected to the carbon number 2, the methyl group connected to carbon number 3. A complete IUPAC name, it should be 2-bromo 3-methyl butanoic acid. So compound B has an alcohol and the ketone in addition to the bromine atom, and according to priority listing, the ketone is more important than the alcohol. That is why its name is 3-bromo-4-hydroxy-benzenol. And number 3, there is an alcohol and the ether and a ring in addition to the bromine atom. The alcohol has the highest priority and therefore must receive the lowest number. So its name would be 3-bromo-2-methoxy-1-cyclobutanol. So the compound D has an alcohol and an ether in addition to the bromo atom. In atom, the alcohol group has the highest priority, so it must receive the lowest number. So its name is 3-bromo-1-methoxy-3-butane-2-ol. Next, you will now illustrate the name. This is your EFGH, and in this, there is the naming is given that which priority sequence is having the mole, and after that, we are naming it. So in this, the first E compound, which is having the name 3,4-chlorobutyl-1-cyclohexanone, and in the F, it is having the one whole bracket 3-chlorocyclohexanide, 2-butanol, and the G and H is having these names 1-chloro-4-cyclohexanide, 2-butanol, 4-butyl-3-chloro-1-cyclohexanone. These are the questions that the organic compounds are broadly classified as a recycled compound, acyclic compounds, and the aliphatic compounds is other name for acyclic compound, and which compound is not example of acyclic compound, that is a C, and which among the following is not the example of acyclic compound, that is acetic acid, and which name of the is not an aromatic compound, that is a pyridine, and find the odd one among the following, that is your C branching. These are the references from where you can study this topic, and thank you so much for today's lecture.